recorded. So take a look at 1.5, and that is on page 28. So go ahead and get your book open. And we've got a couple of new vocabulary words. Vocabulary and your definitions and your postulates, theorems, those are the important pieces of geometry. And so they're always going to have some definitions for you, and you definitely need to make sure that you understand them. So if you look at the top of page 1.5, it talks about a coordinate of points. And if you remember last year, I would give you the coordinates, and you'd have to go on the coordinate plane and find the point. So I think you understand that piece. And then we're going to be talking about distance and length of segments. And a segment is something that you need to understand the definition for. So a segment is going to be not the whole line, because remember, a line will run to infinity and beyond. Isn't that what Buzz Lightyear says, to infinity and beyond? So that's a line. It's running to infinity and beyond. But a segment is a piece of that. And so we're going to be measuring pieces of the lines today. So it's not the whole thing, and it's usually set off by 2 points. So if you look at the bottom of page 28, up in postulate 5, there's an example. On a map, there's an example. Set off by 2 points. The line keeps going, and you see the arrows there, but the segment is just 2 points. Now, the most common place where you are going to see the necessity to measure a segment, if you had been born 50 years ago, I would have said it would have been in an old-fashioned map. How many of you have read an old-fashioned map? A couple. I'm actually surprised. Good. Because now we totally rely on GPS. You know, when you're driving along and Alexa, turn right here, please, and turn left there on Main Street. You know, she tells us everywhere we need to go. She tells us how far we need to go on that street. So we don't have the necessity to pull out old maps and read them. But back in the day, remember, I'm really old, and at one point, so like I know this is going to sound like really scary in the dark ages, but when I was in my 20s, I lived in North Carolina, and I did a lot of traveling through the state, and I had to use paper maps, and I had to travel with no phone. And there were these things at gas stations. They were called phone booths. You know what I'm talking about? Have you ever seen one? And if you had to call anybody, you had to get to a gas station, put your quarter in or whatever, and make your call. But if something happened on the road and you just had to pull over, you had to walk to the nearest gas station. Isn't that like archaic caveman kind of things? And so when I would go on a trip, sometimes I'd have to go 10 hours. Well, I couldn't just call on the phone. Like now my car has one of these Bluetooth, So look how far we've come. Where the phone rings in my car, and I hit the button, and the person's voice is in my car. Isn't that amazing? Who would have thought? But when I was in my 20s, I'm driving across the state of North Carolina with a paper map. And the only way to figure out adequately or efficiently how many miles it was going to be was to take one of these old-fashioned things and to actually measure on the map the routes. And then you'd have to have the scale, and it might be for every inch was 100 miles. So if I had 8 inches, I'm measuring all my little segments along the road. Thank God Alexa came on the scene. I would have 800 miles, right? If I had 8 inches. And then I'd have to figure out, then I'd have to get local city maps to figure out where I had to go. I had to call people on an old-fashioned wall phone and ask them for directions. Now, thankfully, we have moved into this modern technology where I don't have to do any of that. But if you guys are ever in any kind of research, in your science classes, you may need to measure. And you may need to measure angles if you're thinking about being an architect. If you're thinking about being involved in a building process. If you are thinking about mechanical engineering, anything like that, you may have to know how to use these instruments. So, segments and measuring is basically all we're doing today. And if you've ever used a ruler, this, like I said, should be super duper easy. So, who needs a ruler? Some of you might already have them. Do you guys have rulers? Going to do some measuring. You guys have rulers, and a couple there. If you need one, make sure you leave it. That should be fine, yeah, that should be fine. You got that. Yeah, everybody looks like, oh, cool. He's got one on his calculator. You may not use them to hit anybody.
What?
No hitting. They're trying to, I hear them back there doing this.
How
All
am
right.
I gonna hit someone with this?
I hope not.
It has the diameter of an iPhone.
It does.
If
Hopefully you wouldn't hurt anybody.
If I hit someone, the
Alrighty.
person's gonna cause more damage.
So I'm just going to draw a line here. I'm not actually, didn't really measure it if I did that. And remember I said this line is going to infinity and beyond, but we want to get a measurement of the piece between the points. And so what I'm going to do, and I'm going to insult your intelligence now, because I think you guys knew how to measure things probably in 3rd grade. But I just want to make sure. Now on your rule, yes? You forgot what? Okay. And I'll try to grab, if we're going to do a lesson, I'll try to grab a few of these just in case. Now when you measure, the thing that you need to be most careful of is that this is often a tad longer than 12 inches. And it starts with the first mark, generally a little ways in. So that's the only thing you have to be really careful of. Because you want to get an exact measurement, but you need to realize that that first mark is probably a 1/16 of an inch in already. So you need to make sure that the first mark is what's actually on your first point. So make sure that you recognize that. And then hopefully the points are a little smaller, you know exactly. Now this is exactly 8 inches. And when you guys measure, you're probably not going to get a nice even number. So what I want you to do is look at the bottom of the page. There's 2 segments there, AB and CD, and that's just how we name them. The 2 points, AB, segment AB, segment CD. I want you to measure, and it says go to the nearest 1/8 of an inch. So measure those and tell me when you have the measurement to look up. And tell me what you find. On page 28. At the very, very bottom, you don't have 2 segments down there? Is it just metric or is, I'll come get this one. I would throw it, but I'd probably hit that right there. Or Josh. Amelia, can you pass that? Sorry, if you have a metric one, you can come up and get a different one. You had it the first year at FEC? So has anybody gotten that first one, AB? What do you have, Logan?
I have 2 inches and a 8.
An 8, yeah. So
I think. I do not understand why this ruler only has 7 notches in between the things. It's messing with my brain.
Sometimes I actually start at the 1 inch mark. Huh.
So it's 3 inches?
No. No, I start there just to get it more accurate. Did anybody get anything different? Anybody get anything different? The answer is supposed to be 2 and 1/8 inch. Is that what you got? Okay, and then I've measured with 2 different ones, and they're slightly different. I don't like this one. And then what did we get for the second one? Anybody? Want to tell me what you got for the second one? What did you get, Ms. Keeper? You got 1 and 4/8. So what would 1 and 4/8 be? 1.5. Yeah, good. Okay, so the careful thing is just to make sure you're lining it up well, because you do want to go for exact measurements. Now, our next postulate, number 5, hopefully you had a chance to write these. If you didn't, there's index cards up here you can grab. And there's the old map that I'm talking about. And so if I went between Albany and Athens, or Albany, some people say it that way, and I needed to work on that scale, I would first measure, and then I would use the scale to help me figure out how far I needed to go. So they tell you to find the distance, but what they did was they threw in another point in here, which is Macon. And I'm assuming this is Georgia. And so let's say that I'm leaving from Albany, and I'm going to do a pit stop in Macon and visit a friend. So what I first need to do is measure from Albany to Macon, and it tells me there that that's 90 miles. So I go, I leave on a Friday, and I'm going to spend the night with my friend. But then the next day I have to go from Macon to Athens, and that's going to be another 80 miles. Well, this postulate just says, and I know this is insulting your intelligence again, if B is between A and C, then AC, the whole thing, equals AB, the time it took me to get to Macon, plus BC, the time it takes me to get to Athens. Super easy, right? You could take a test on that right now. It would be super easy. So if I have a couple of points on the line, then I know that from point 1 to point 2, that's one distance. Let's say that's 1 million. And point 2 to point 3 is 2 million. My total is 3 million. So don't overthink this. Don't try to make geometry hard all of a sudden. It really is that simple. This little segment plus this little segment equals the whole big segment. You could write that example on your card, but to me it's the easiest of all the postulates that we have. Same thing. Let's say somebody says, oh, by the way, your trip from Albany to Athens is going to be 170 miles. I just did it last week. It's 170 miles. I might want to find out how much it is from just Albany to Macon. So I might look at Mr. Smith and say, well, how far is it just to Macon? And he might be able to tell me, and then I would subtract it. So you can either add those two, or you can subtract information to help you know what distance you have to go. So let's do that. We're going to look at page 30. And there's 2 checkpoints. You're going to take your trusty ruler again. And it says find the length of AC. So we're going to be looking at 2 smaller segments, and we're going to add those up to get our big segment. So first you're going to do A to B and come up with that.
Where are we?
We are on page 30. And I think by their answers, we might be doing, are we doing centimeters? Oh, they give you the measurements. You don't have to measure anything. So if I've got 14 between A and B and 6 between B and C, what's my total? Shouldn't have to measure anything, I'm sorry. What's the total?
20.
20. Now, if I have a total for S and R, for SR, I have a total of 23. So it'll be 23 miles to SR, wherever that happens to be. But I want to make a pit stop at ST. And I know that from TR, it's 15. So what is the missing piece? It's like one of those little puzzles. 23 is my total. I know there's 15 in that second segment. What's in the first segment, Amelia? 8. So you can add them, you can subtract them to find out your information. Now I want to point out one more thing, and then we'll do a little bit of measuring so that you can practice this next thing. You have probably heard this word, congruence. Does anybody know what it means? Something is congruent. It is, any ideas? Well, I will tell you. It means it's equal. Now you can have congruent triangles. You can have congruent squares, you can have congruent circles, you can have congruent segments. And if you have something that is congruent, we're going to assume these are congruent. You can put this little symbol, it looks like quote marks, to indicate congruence. If you had 2 lines on triangles, we know this one is equal to that one because maybe we measured it or somebody told us. We would indicate it by using that little quote sign. They're congruent signs as well. It's important to know that you can use, remember we did those puzzles the other day and you had to think through patterns? Well, as you get closer to solving proofs, which is kind of what we're working toward in geometry, or we want to prove different statements, it's important to remember some of these things. And so knowing that you can have congruent objects, that segments, sides of triangles, whole triangles, is one of those important pieces to help you solving problems. So if something is congruent, it's shown in an equation. I said A, B equals CD. Instead of saying that, if you look on your halfway down on your book, you can also do it like this in Geometry World. So you just add like this little squiggly line, and it's another symbol for the congruence. Okay, so what we're going to do, we're going to measure some of these lines are over here on page 31. You are going to measure and figure out if any in number 5 and number 6 are congruent. So look on page 31, and you want to take your little trusty ruler. It might be easier to use millimeter or centimeters. And you want to measure them. And you want to see if you have anything that is congruent in there. And I've already found one. So you're doing number 5 and number 6 of the guided practice on page 31. You're going to measure, it's on the coordinate plane. You're going to measure those lines and see which ones might be. So all you're going to be doing for homework for this lesson is actually just some measuring. Anybody know? Logan, tell me what's congruent.
E, F, and C, D.
So you said GF
E, F,
and
and
C,
C, D.
those. I'm looking at the wrong place. Yes, EF and CD. Now, how about on number 6? How about somebody else? We have another brave soul. Who would like? Go ahead, Josh. Correct. So it's those two that are sitting, and you can see that they're parallel, and it is those for sure. So super easy. Sorry to insult your intelligence. Maybe the next one will be a little harder because we're actually going to look at angle measuring. So why don't we take a little break, and I am going to go. I'm trying to think. I have this giant protractor, and I'm trying to think where it is. I think it might be over at the parish hall. So I'm going to go over there. But let's go out here on the lawn, and you can take your break. And I'm going to go see if I can track that down.